Alright, I'll do all of these to be fair, right? So question 1. Differentiate sine 2x. So y equals sine 2x, dy dx equals. So you go to your maths tables on page 25 and you look for what sine x turns into. Sine x turns into cos x. So what you've learned here is that sine turns into cos. Two things to remember. The angle never changes. The angle never ever changes. So what happens? Stays as 2x. Next step. Differentiate the angle. What you get? 2. The answer for this question is 2 cos 2x. Okay? Now, do I understand that? I don't remember understanding that. Like, I think there's formal proofs that are college level stuff. Can I remember that? Absolutely. Alright? So it carries through to all of these. Right? You go for cos x as well. You go y equals cos 6x, no bother. And you're like, okay, cos 6x. What does cos change into? Nearly minus sine. So cos turns into minus, and what did we say about the angle? Never changes. And what was the other part? Differentiate the angle. Oh, done. Not so bad. We good so far? Alright. Now, we go for argument's sake, we go for tan. This one here. Okay? Tan x squared. Okay? Once again, I go looking, go into my tables. Okay, what's tan? Oh, tan is secant squared x. So I replace tan with secant squared. See the way the tan turns into the secant squared? The angle, what did I say about the angle again? It's the same, thank you very much. And what did I say we also have to do? Differentiate that. Okay, 2x secant squared x squared. Done. We alright with that? Alright, in class now, will you quickly try the following? Okay, and I'll obviously do them for you in a minute. The ones highlighted in green. Okay. Okay. So tan 4x, if I remember correctly, tan turns into secant squared. Angle never changes. Differentiate the angle for secant squared 4x. Okay. For part 5, y equals cos 3x minus 1. Cos turns directly into minus sine. Angle never changes. Differentiate the angle we get. Minus 3 sine 3x minus 1. We go with that. Right, next one. Cos turns directly into minus sine. Angle never changes. Differentiate the angle. Differentiate x squared minus 1, we get 2x. They're actually not bad, are they? Provided you actually can remember or you study before the test. Usually helps. Alright, now what does sine turn into? Cos 2x, differentiate the angle. 2. Cos turns into minus sine 4x, differentiate the angle. That's 4. Alright, easy peasy. Strive on. Alright, now what's different about these ones is in questions, I'll do 2, 3, and then you guys will do 4, okay? So I'll do 2 and 3, and then you guys will do 4, right? There's going to be a bit of a chain rule here, okay? So see that tan squared? That's tan theta to be squared. Would everybody agree with that? Okay. Now, what's the chain rule again? What's the chain rule? Bring 2 to the front. Yeah? Sorry? Minus 1 from the power, which leaves it as the power 1, doesn't it? And then you have to differentiate the missing part. And the missing part is actually tan theta. So what's the derivative of tan theta when you look up your notes? Yeah, secant squared theta. So is everybody happy with that for the chain rule? And then what does tan 2 theta turn into? Tan turns directly into secant squared. Angle remains the same. Differentiate the angle. 2. By the way, we did differentiate that angle. It just happens to be 1. That's all. So we didn't even bother with it. Alright. What do you reckon for part 3? Part 3. What do you recommend? We'll go for Mooney. Mooney, what does cos 4 theta turn into?
Minus 4 sin.
Yeah, it turns into minus sin 4 theta. And then you did correct, you differentiated the angle, didn't you? And you got 4. Alright, now what about the next one? It's already a minus. So what does cos theta over 4 turn into? Just that part there.
Sine.
Minus sine theta over. Now you have to differentiate the angle though. You have to differentiate that angle. Are you a bit confused by it?
Yeah.
That's alright. If you had 4 theta, what would the answer be?
4.
Okay. If you had 10 theta, what would the answer be? Okay. If you had a quarter theta, what would the answer be? A quarter. So see theta over 4. That's the same thing as a quarter theta. So the answer would be a quarter. Now what's minus multiplied by minus? Yeah. Alright guys, try part 4 on your own. Before we differentiate, I'm going to rewrite it as y equals tan theta to the power 3. Alright, so when we differentiate Comiskey, what happens to the 3? What you do to the power? So 3 tan squared. And then what happens when you differentiate tan theta? Yeah, and when you differentiate the angle, which is just theta, it's just a 1, so you don't even have to put it down. There's your answer, good job. Yo.
Since sec squared theta is 1 over tan squared theta, and you're multiplying it by tan squared theta, isn't that equal to 1?
No, so Charlie is familiar with the rule on page 13, where secant squared theta is equal to, what's it, 1 plus tan squared theta? No, I'm looking at it. So you just end up multiplying out a bunch of numbers. You could do that if you wanted nothing but tans, but it's not necessary. Alright. Now, next one. Okay guys, we're going to give you guys a go at this. What would you identify this as? What do you reckon? What do you reckon it looks like? 2 different colours. Product rule. So let u equal x, let v equal cos x. I want you guys to do the product rule, and then once you do the product rule, replace x with pi and see how you go. Off you go. Oh, fun times. Now, the u dx is 1. The v dx, differentiate cos x, and we get. Now, what's the product rule? It's nicely on your tables here, isn't it? U times the v dx plus v times the u dx. So u times the v dx plus v times, which is cos x times the u dx. Now, some of you guys might not be familiar with this, but do you remember back in the day where if I wanted to multiply 5 by cos 30, you simply say 5 cos 30. You do not say cos 150. Do you get what I'm saying? The angles remain unchanged. The angles are almost untouchable unless you cos inverse. So you never really touch the angles, ever. It's very, very rare that you go near the angles, okay? So what happens when I multiply x by minus sine x? What do I get? minus x sine x, exactly. Was anybody confused about that? Alright, we're all good. Happy days, alright. Have a quick look at this again. Oh, I didn't finish the question properly either. Give me a second. What I was meant to do, x equals pi minus pi sine pi plus cos pi. Now, go to your calculator. And on your calculator, we're going to make sure it's in radian mode, so it should be an R on the top of your calculator. If there's not an R, go to Shift, Setup, Angle Unit, and make sure you're pressing radians. And now we got minus Shift pi, oh god, minus pi sine pi plus cos pi. I think the answer is minus 1. Yeah. Yo.
Is it just whenever you're using like pi, you know, to put your calculator in radians?
Yeah, basically, yeah. Because it's an angle. X is an angle, and the angle is pi. Alright guys, let's keep going. Alright. Give it a go. 11. Off you go. So, sine differentiates into cos. Cos 2x. Differentiate the 2x to get 2. Alright? Oh. So, who got 2 cos 2x? Okay. Looks nothing like sine squared x, does it? Right. Is there anything we can do about that? What's cos 2x in your notes? Go on, call it out. What does it say cos 2a is? Give it to me. Cos squared? Now, if I'm looking at these notes here, yeah, I'm going to go for cos squared a minus. Right. It's still, so, if you will, I'm just working on the cos 2x part. Is that okay? The cos 2x part has nothing to do with my answer, and I'm just going to work on getting rid of it. Right, so that's cos 2a. Is that okay with you guys? And therefore cos 2x would be the same deal, wouldn't it? Who got that far? Alright. What do I not want here? I don't want this either. Do I want cos squared x in my answer? Anybody have a suggestion how to get rid of cos squared x? What'd you say? Yep, who said that? Good man, Tom. Tom was smart enough to realise that cos squared x equals 1 minus sine squared x. So Tom's going to sub it in here, and he's going to get 1 minus sine squared x minus another sine squared x, and long behold, that's 1 minus 2 sine squared x. The only reason I knew to do that was because it told me specifically that the answer had sine squared only in it. So first I had to get rid of cos 2x, and then I had to get rid of cos x, because cos x did not belong in the answer. That's where the logic came in. Okay? Now, Chaddy.
You've got a 1 in your answer though, should you?
Give me a sec, Chaddy. All good. Now, Chaddy, what I basically said is this. I didn't actually do the answer yet. What I said is cos 2x is the same as this. They're the same thing. So I'm going to multiply this by 2. And what am I going to multiply it by 2? 2 minus. And then there's still the minus 2 from here, isn't there? And what happens to the 2's? Does the answer I just got fit the description of the question? Of the answer? And the k value is? Minus 4. Is k allowed to be negative? What does that mean? K is an integer. It can be positive or negative, which means I'm happy with my answer. Ready to move on? Okay. Lads, you're actually alright with this one. Differentiate that to get f dash x, differentiate this one to get g dot x, add both answers together to get equal to 0. You're capable of doing that. I'm not gonna go there, right? But what I will go for is question 18, isn't that right? Woo-hoo-woo. Alright, look at that bad boy, lads. That's what it's about. Alright. Now, anywho, this question here is essentially this question here. Differentiate it. d dx means differentiate this part here. Once you successfully differentiate this, your answer should look something like this. Differentiate the yellow part and your answer should look like the green part. What type of rule are we going to use? Quotient rule. For those of you at home, a big call out to Kev. He's probably back in the States, but we're going to use the quotient rule, which is this one here. Alright. Now, alright lads. U equals sine x. What about the u dx, lads? Phi equals, what is it? The v dx. We go. Alrighty. Now let's do the quotient rule, right? Phi times the u dx minus u times the v dx all over phi squared, is it? Which part are we very happy about right now? I think the denominators look exactly alike, don't they? 2 plus cos x squared, 2 plus cos x squared, right? And let's multiply at the top, and what do we get? 2 cos x plus cos squared x, yeah. What's minus sine x by minus sine x? Anybody know what to do with that? Cos squared x plus sine squared x equals 1. And my answer is 2 cos x plus 1 over 2 plus cos x squared. Is that right with you guys? Now, do I have to match that to my answer? Alright, would everybody agree that the b value is 2 and the a value is 1? Alright, so in today's class I did 11, 18, 7, 11, 18, 1, 3. I did 1, 3, 7, 11 and 18, alright? So you guys will do questions 2, 4, 6, 8, 10, 12, 14.
Steady.
I'll stop.